So we've done either Sybil test or we've done this bootstrapping mediation. Now there's, as always, people update things. There's newer versions to do the same thing. And there's another method, which is you use the site package. There's also a package called appropriately the mediate package. If you click the link, there's a paper behind it, hopefully. Long story short, this is a newer and perhaps better method of estimating mediations. Now it looks slightly different. So after you've installed mediation, you can call it, and then you use met.fit. This is the first, this is the mediation part, and this is the actual model for the so it looks different than what we had in Psych, but it's a similar type of principle for what we do. So what we then have to tell it, so because everything is bootstrapped, you have to set a seed, like your favorite year or whatnot, to make sure it's replicable. So in this case, it will not do robust standard errors for because we're doing bootstrapping, but I'll come to that in a bit. So we say met.fit, out.fit. We tell it which one is the independent, which is called treatments. We tell it which one is the mediator, which is M. And then we tell it to bootstrap it. And we say, rather than boot or iter, we say 10,000 iterations. Yeah. So slightly different layouts. We're doing roughly the same thing. Now the output you get is something like this. It says causal mediation analysis. And now it says ACME and ADI and total effect. But this seems quite similar to what we had before, right? So this is this average direct effect, and that's the type of thing that we really care about, whether that changes. And so this is the output that you get from these ACME, from these effects. So you can see that this is the one that has dropped to 0.04. So it will then also give us the proportion mediated, and that will be an estimate, 90%, which makes sense because we had 0.4 going to 0.04. So 90% is mediated, and we have a 95%. You don't have does it print a 95% confidence interval? No, it doesn't for that. Either way. So the mediation analysis showed a significant average. That's how you write up. So in the report is average causal mediation effect, 0.36. It's 95% confidence interval. And then you can say the average direct effect was no longer significant. So that was the same thing that we had with this arrow not being significant. It's just a different terminology. You can look at the papers, but these people prefer ACME and ADI to sort of do this type of phrasing. You can also get a plot from this. This is sort of what it looks like. And the nice thing what you can do, what you couldn't do with the site package, is it can do some sensitivity analysis. Long story short, so this is a long blurb of text saying the sequential inorderability assumption must be satisfied in order to identify average mediation effects. The key assumption implies that the treatment assignment is essentially random after some adjusting for the observed pre-treatment covariates, and an assignment to median values is also essentially random. So this was where I said, if you experimentally manipulate the mediator, you have some control over it. If you don't do that, then you don't really know what's going on. So in essence, it's saying it could be in your design that there was something hidden, like a hidden confounder, which explained both the independent variable and the mediator. And so if we had built a perfect model, then there would be no unmeasured confounders, but actually it could be the case. And this is testing us like how strong those hidden confounders would have to be to overturn the relationship. That's it in a long story short. So you could also think of it as the following thing. So it corresponds to the correlation between the errors in step 2 and step 3 of the regression equation. So in a perfect world, you have this Barron-Kenny method. You have step 2 and step 3. All regressions have some type of error estimates, and it's assuming in a perfect world that there is no correlation between those errors. And if there is, then there's a hidden confounder. So in this Barron-Kenny method, it's assumed to be 0. But it's actually something which we can estimate or try to guess. And this parameter is denoted by rho. That's just the terminology they use. And under sequential ignorability, rho is equal to 0. And so we assume, so if there are no hidden confounders, then we satisfy the Barron and Kenny type thing, and it is 0. And so any value of rho that we estimate which is larger than that means we're departing away from this assumption of sequential ignorability. long term, but that's basically what it amounts to. So basically, if you had a perfect world and you were able to manipulate everything, then there can be no hidden confounders, or it should be very improbable. But most of the time, you will have some possibility of a hidden confounder. So basically, something which you didn't measure, which is influencing all the other variables in your model. Yeah. So we can do this like as follows. We can say sensitivity analysis medsense, and then for a med.out object, and we can tell it to increase by 0.05. And so this is then saying what the sensitivity region is, and this is basically trying to estimate where our effect would fall away. So how strong this correlation has to be, rho, in order for us to no longer find this mediation effect. Yeah. So lots of outputs, but it's doing in this case steps by 5 to sort of see where it crosses over and is no longer where it actually becomes 0. Yeah. That's sort of the logic behind it. And so this is the rho at which this happens, which it can then estimate, and then we can have some further terms which they like, which is we can look at the proportion of previously explained variance in the mediator and outcome variables that is required to be explained by an unobserved confounder in order to render a mediation of 0. That's this beast here. So at 30% of variance, our mediation will collapse. Yeah. So that's how strong it. So if we have 30% of unexplained variance previously, then that would. So if that confounder happens, then there's no longer mediation. So that's quite big, right? So it's a lot of variance. So you can think of 100% variance as explaining everything. 30% is roughly 1/3. So we need quite a big confounder in order to explain, to make sure there's absolutely no mediation left. Yeah. And this is how much how much of the proportion of the original variance explained by an unobserved confounder is required to render the mediation effect of 0. So this is going to be a much smaller value because the one is looking at all the variance. This is looking at the subset of the originally explained variance. And so in this case, this is this value. It's around 14% of variance. So this is how much of the previously explained variance would have to change in order for this confounder to no longer give you mediation effect. So this is very, very advanced, high-level stuff. Most of the time, you would just do these bootstrapping effects and you wouldn't really worry about it, but I'm going to tell you about it so you can do all these sensitivity checks if you wanted to do it on your data. And so depending on where you stand, this could be a large or a small effect. Again, it depends if you're in biology or in some other fields, like how much variance you're comfortable with, like explaining away this mediation entirely. But 14%, I would say, is quite a big chunk of variance that you would need in order to overturn this type of previous effect. Yeah. So you can read papers because this is quite dense, lots of things to go into. So you can read papers if you want to find out more. But it's basically some checks, because otherwise if we don't manipulate all our variables, we don't really know everything is correlational, and there could be something hidden in our models which explains away our mediation effect. Now, a critique, and while we'll also talk about some in the future, is like you could fit many different models to this type of thing. So you had the option, probably, you also measured lots of other variables. You could have the option to build lots of models with lots of arrows. Yeah. So how would you know? So you might have. Did you also measure some other variables in your, or was it just those? Just That's very good, because sometimes people just measure 20 or 30 different variables and then just. You would be able to draw so many arrows and able to add so many mediators that you could do whatever you want. So perhaps a model with several main effects. So we don't really know, we might have established mediation, but we don't know how much better this model would be to a model with just main effects. Yeah. So we haven't done that. So you could potentially find a significant mediation effect, but this model could only be marginally better than a model with just the main effects in it. Yeah. Does that make sense? So we'll come to this when we come to structural equation models, where we can actually compare and say this model is X amount better supported than this other model. Just because you find evidence for this pathway doesn't necessarily mean this is a good fitting model to the data. Yeah, so you could find evidence for a mediation effect and a statistical mediation effect, but you could have jumbled the variables and also found a mediation effect. You could have done other types of models. So it becomes very difficult to say, is this the best fitting model or not? You should also bear in mind that if you're doing multiple mediators, so in this case you had a scenario where you had 2 mediators, what happens in these estimations is that they will be averaged. So I'm not sure if that was the same in your analysis, but they will be averaged. So if you're doing the statistical significance testing, the effects for those mediators will be averaged. So it could be that one is doing all the legwork. Now in your case it was perceived shame but not perceived stress that's doing all the legwork, and the other one is actually not contributing a lot. And especially if you go above 2 and you have like 3 or 4 of these mediators, you don't really know which one is carrying its weight. And we can do that also with structured equation models. So there could be a scenario where you have 2 significant mediators, but actually perceived stress matters a whole lot more than perceived shame. And you wouldn't be able to tell in a very easy way in this type of setup which one matters more. So that's why I'm also going to continue with mediation in structured equation models to tell you more. Now, if all went to plan, you will have a data set online in the exercise thing, which is the PEC mole data. The file contains data on 95 women performing or completing various skills, psychological skills, and body image related tasks. So they do a gap estimation task to see if they fit, or if they think they will fit through some doors. We actually also know through which thing they would actually fit through, and then we have some measures of BMI, and also their subjective estimate of their own BMI. I would like you to test this mediation model first via the Barron-Buchanan method, and like report it as you would do in your in a paper. I would like you to make a diagram, like using this mediate thing, as you've just done now. I would like you to do a Sobol Z test and report it. I would like you to test the mediation via this bootstrapping thing which you've used. And I would like to now also, I've only talked about one mediator, but as you had in your model, you might have 2 mediators, so you might have perceived stress and perceived shame. In this case, you might have PEC and mole. And so you have the same independent variable and the same dependent variable. Now you have 2 mediators. I would like you to make a figure for that. And then I would like to use this more advanced method, which also does this sensitivity analysis, and that's really the bonus. So that's also why I didn't dwell too much on this. Some things I tell you are really core, and like I would really like if you were all using sensitivity analysis, but this is really the frontier where we're at. So that's all I had to cover, and so there's some references at the back also where I got some of the data. And any urgent burning questions or things? We're stopping slightly earlier today. So as you might have also understood, like the course is quite heavily front-loaded. So in the beginning, I will go quite fast because a lot of it is also revision. It's correlation and regression and t-tests, which you have seen. The pace will sort of a little bit slow down as we move to structured equation models, factor analyses, multi-level models, these more complex topics. Any questions? So Alex has posted how you would get this package PDA to work, which you would need for this exercise. So if you run those through the steps, you're able to install the legacy version, and then it will just run fine. If you don't, then use the discussion board also to post questions and say, I can't get this to work. And unfortunately, some of you are still facing problems with like your My Documents not being mapped onto your U drive. And so that's going to be specific to certain PCs. And I suggest you talk also to IT if that's you. So if you have issues with your My Documents and your U drive not corresponding, and you not being able to read or write data in folders where you should be able to read writing data, then you need to talk to IT and log a ticket with IT to solve this. But you didn't have any issues, right? So there was no issues installing packages and running it. So it's just like in the beginning we faced some issues that if it's in My Documents and it's not in the U drive, then it doesn't really like it, and then things go horribly wrong. Any questions? So I've rushed perhaps a little bit through the, but just have a look again at this EMI and Tingly and these more advanced methods. It'd be really great if you start using them, but it's really, really high-end stuff, which most of your supervisor will also not know of. So if that's it, then next week I think we're doing factor analyses, so I'll come back there. Yes? Okay, I'll come and talk to you unless it's a class-wide issue. And then you can stay, and again, this is something like you don't have to stay, this is something which we offer extra, but you can stay if you want to talk about your exercises with Alex and Sarah. And again, it's up to you. If you haven't made your exercises, it's time to catch up. because it's rapidly approaching. And again, for your assignments, the best thing to do is to run the exercises first, because the assignments will correspond quite good or quite well with the actual exercises. Okay.